So first thing we're working on today is finding probabilities of normal distributions on the calculator. Now we've done this before, finding the probabilities. We did this before by finding your z-score, and then you go to your table, and that number off the table was your probability of getting whatever score it was you were looking for, or less than that score. And then remember, we can take that probability, we can also turn it into a percent. So what I'm going to be teaching you first today is how to be able to get that score off the table, but using your calculator. Instead of having to find the z-score and then going to chart, there is another way of being able to do that. The one thing you have to keep in mind, though, is on that Regents exam or on your test for your statistics, is if they ask you for the z-score specifically, you can't do it this way. You actually got to find your z-score. But if they ask you for the probability, you can use your calculator every single time. So what we're going to be doing is we are going to be using this function called normal CDF. So that's code for finding the probability underneath the curve. So the way we do this is we need to know a lower bound, an upper bound, your mean, and your standard deviation. So now with those lower bounds and those upper bounds, what happens is a lot of time that is negative infinity or positive infinity. Like for example, if we're dealing with this one down here, when we're talking about getting a score less than 500, that means I could have 500, I could have 0, but really is there an endpoint to that? No, so our lower bound in that problem would be negative infinity. However, we can't type negative infinity into our calculator. So your lower bound that we would end up using, if need be, is negative 99,999. We have found that ends up being big enough to be your lower bound since we can't use negative infinity. Same thing goes when we're dealing with our upper bound. So like C here, when you're looking for a value larger than 720. You could have any number up there, but there's really no end to that. There's no end to picking a number there other than infinity, but we can't use infinity. So positive 99,999 works suitably as your positive infinity. So 5 nines, whether it's your upper bound, lower bound, 5 nines. Even though we are going to be using our calculator, you should always draw yourself a sketch so you understand what it is we're actually looking for here. And you also have to write down what it is that you are typing into your calculator. That is important. So for these 4 problems down here, we're going to use the same thing. We have a set of scores on a standardized test are normally distributed. We have a mean of 560 and a standard deviation of 75. So they want us to find the probability that a test picked at random would have a score less than 500. So for our picture, we're going to start with our mean right there in the middle. That's 560. If we were to go 1 standard deviation below, what would that value be? So 560 minus 75. 485. So since I'm looking at 500, 500 would fall approximately in there. It'd be in between my 560 and my 485. So my dotted line right there is 500. So we're looking for 500 or less. So we're looking to the left of our 500 value. So our lower bound for this would be what? We're looking for the less. So our lower here would be negative infinity, but we can't use that. So we're going to end up using our negative 99,999. So for what we're going to type into our calculator, we're going to use the normal CDF function. So we write normal CDF first. Not there yet. We're just writing what we're going to type in first. So it tells us we always have to put our lower bound first. So that would be our negative 99,999. Next number would be your upper bound. So in this case, it's going to stop at 500. That's our upper bound, because we're looking for the scores less than 500, so it would be negative infinity to 500. Then it tells us next is going to come our mean. So it would be 560. And then last would be our standard deviation, which would be 75. So now your calculator is going to look in two possible ways when we do this. So in order to get it, we're going to hit the second button, and then you're going to hit the vars button. Second, and then vars. If you forget, I do have that written in your notes right here. Second, and then vars. So we want the second one here, normal CDF. That's going to be the one we pick. And some of your calculators may look like mine. If it does, you're going to type in these numbers with the commas just like we wrote it right here on your paper. So negative 99,999. And then comma 500. Comma 560. Comma 75. Yeah, I'm going to get to that in a second. These are for the people whose calculators look like mine did up here. For other people, your calculator has created a list where it says lower, upper. I believe it's got the symbol for mean, but it wants the mean next. And then I believe it's got the symbol for standard deviation, but that's what the fourth one is. And then it says paste. So what you're going to do for this problem is you're going to type in exactly how we have it written on the paper. Our lower bound was negative 99,999. Our upper bound was 500. Our mean was 560. And then your standard deviation was 75. So you type them all in, you go to paste, and you hit enter. And after you paste it, you then should have something look like I have on here. And then we hit enter. Our table always gave us values that were to 4 numbers after the decimal. So when you do the calculator, you're going to do the same thing, 4 numbers after the decimal. So 0.211, and then what would this one be? 9. That's our probability of getting a score less than 500. All right, let's try the next one. Find the probability that a test picked at random would have a score less than 720. So again, I'm going to put my mean on there. 560. 720 is larger than that, so let's start adding our standard deviations. 560 plus 75. Yep, and then plus another 75. 710. So 720 would be just beyond the 710. So then we want 720 or less, so that means we're going to shade this way to the left of it. So since it wants the or less, what is our lower bound going to be? When it wants the or less, your lower bound is negative 99,999. Our upper bound, which is our next number, is where we're stopping at. We're stopping at 720. Our third number is our mean. Fourth number is your standard deviation. So we'll type it in our calculator. So second vars Get your normal CDF. And then type your numbers in. So what did we get? Point, what? 9836. So now part C, this one's a little bit different. Find the probability that a test picked at random would have a score larger than 720. So since I'm still using the same number as the last one, I'm going to fill in my numbers there. So 720 is just beyond our second standard deviation, which was 710. We are looking for the probability of getting a score larger than 720 this time. So we shade to the right of it. We're looking for those numbers. So this time, since we're looking for a number larger, the probability of a number larger than that, when we go to write our normal CDF, our lower bound this time is the 720. That's the lowest score we're looking for. We're looking for the probability of scores higher than that. So our upper bound this time is 99,999, positive 99,999. And then the last two are same, still mean, 560, standard deviation, 75. Because we're going for a score larger than that. So our smallest number this time is 720. So if you did it correctly, you should get 0.0164. All right, and then our last one over here. Find the probability that a test picked at random would have a score between 500 and 600. So to make our picture, as always, again, put my mean right there in the middle, my 560. One above is 635. One below is 485, so my 500 and 600 are going to fall in between those. 500 would be approximately here. 600 would be approximately here. And we're looking for the probability of falling in between those two. So since they gave us two scores this time, we don't have to use the special upper bound, lower bound. So for our normal CDF, our lower bound is the 500. That's the lowest test score I'm looking for. What's the highest test score? 600. So that's our upper bound. And then the last two are the same. Still mean of 560, standard deviation of 75. So go ahead and type that in. Anybody get an answer yet? 4912. All right, so I want you to try these three on the bottom by yourself. You don't have to sketch a picture. But remember, you do have to write what you're typing in the calculator.
I got 0.
0? I'll come look at that in a second. Given that the volume of a soda is 12 ounces, a factory varies normally with a mean of 12.2 and a standard deviation of 0.6. Use your calculator to determine the probabilities. So again, try these three on your own. All right, so these are the answers you should have gotten. For A was 0.0912, B was 0.0228, and C was 0.5698. How'd we do? Thumbs up, thumbs down?
My calculator actually works.
All right. I feel like it's an operator error there.
What do you mean? Like the OS?
No, the operator.
Me. I'm an error.
Okay. Let's go to this next one. Now, questions involving this. There are three types of ways that we collect data. Questions involving these are so easy. I always pray that there's a whole bunch of them on the Regents exam because they're so uber easy. So our three ways of collecting. Guys, stop the conversation back there. would be surveys, observational studies, and experiments. So, when you hear the word survey, what do you think to yourself? What is a survey? Yeah, that's what Devin just said there. Questions asked of participants. That's all a survey is they ask people a whole bunch of questions to get their answers for it. Sometimes you have choices with your questions. You have to pick one. Sometimes they're, fill in the blanks. What are your actual thoughts on something? Surveys are not generally used very often. You use this when an observational study cannot be done. So some problems with this is generally surveys, you are a lot more likely to get some bias or flaws with them. Reason being, a lot of way that companies today or businesses, they conduct surveys is they call people. And now with caller ID, if somebody sees a phone number they don't know, what do they usually do? Don't answer it because you don't want to be talking to those people. Or you don't want to be scammed. I made the mistake today. I answered a phone call because I thought I knew what the number was. And the person says, "Oh, congratulations. You stayed at one of our resorts recently." And I was like, "No, I didn't. I haven't gone anywhere like in the last 3 years." So no, I did not. They can't hang up. So you just keep going and messing with them. They cannot hang up on you. But so there's bias and flaws. There's only certain people who are going to participate. Or let's say, example, you're in a town hall and they're trying to take a survey on who wants a new bike path somewhere in the town. Well, generally the people who are going to respond to that survey are the ones who want it, and not usually the ones who don't want it. So there's a lot of flaws with doing a survey. Another thing is you can't generalize your information unless a sample is randomly selected. And then again, with a survey, though, you can't really randomly select people because only certain kinds of people are actually going to answer them. You can try to offer like free stuff, but again, whatever it is that you offer kind of determines the people who are going to answer it because only certain people want those things. If you're trying to give away a skateboard, I'm not going to answer that survey. I don't want a skateboard. I don't need a skateboard. Can't. And also, you cannot determine a cause and effect from a survey. So our observational studies, what those are is basically you watch something and then you report your findings. So you just watch stuff and then you report it. You have to make sure that there is no attempt to influence the data. You have to remain completely and totally out of it. So, for example, it's very tough to do observational studies. I remember when I was studying to be a teacher, I was an elementary school teacher at first, we had to do observational studies on kids. So we had to go in the room, we had to literally sit in a corner, pick a kid and watch them, like for multiple days. And you had to just write down what they did, write anecdotal records as they called them. But, yeah, if they picked their nose, I had to write it. But the problem becomes, can you sit in a room of kids without them interacting with you? Especially if they're elementary school kids? No, they want to know what every single thing is in their room. So I had kids always trying to come over and talk to me. What are you doing? What are you writing? What's going on right now? I'm like, just go. Yeah. I did for a while. I was pretty good at it, too. Those kids knew math, let me tell you.
Oh, yeah, because 2 plus 2 is kind of hard.
2 plus 2 is 5.
It is. I still have students now who 2 plus 2, they grab a calculator. I'm like, are you kidding me? Okay. Anyways, you can use this when you can't do an experiment. Use when you can't do an experiment. And again, one of the most important things is you need to randomize in order to be able to generalize to the population. So if you want to be able to take the results of your observational study and make a comment regarding the entire population as a result of that, you need to make sure what you're observing is completely random. It's not always the same kind of thing. And so then our last one, our experiment. The researcher has 2 groups, a control and a treatment. No, that's not what I meant. Treatment. So a problem with an experiment is they're not always ethical. So you got to be careful with those. As a result of an experiment, though, you can claim cause and effect. This is actually the only one that you can claim cause and effect after. Observational studies and surveys, you cannot. You got to watch for hidden variables that may skew your data. So that's something that may affect your outcome that you did not predict to be in there initially. The way to make it best is your experiment should be blind. Do you guys know what it means to be a blind experiment? Danielle?
When the person doesn't know what they're getting and the person taking it.
Yeah, everything's completely unknown. The person doing the experiment doesn't know who's in what group. The person that's participating in the experiment also doesn't know what group they're in. So it's completely blind. They don't know what's what until you look at the results at the end. And you always have to watch for the placebo effect. You guys know what the placebo effect is?
Placebo is a sugar pill.
It is. So the placebo effect is when people participate in a study and they think that they're getting the drug, so then they start saying that they're feeling better and it's amazing, but they're really not. They're just getting the fake pill, not the actual pill. Pill filled with sugar. I don't recommend that for the people with diabetes. So what I want you to do, read through these 4 scenarios, and I want to see if you guys can figure out whether it's a survey, an observational study, or an experiment, and then tell me why. You just got to look at the criteria up above to figure out which one it is. All right, let's take a look at this. So A. That one was an experiment. You actually assigned treatments to subjects, so that makes it an experiment. B. What was B? Observational study. They watched and reported after the fact. C. C was a survey. They just asked questions of the participants. And then D, observational study. That one was not an experiment because they did not assign people to move next to the electrical lines. They just did. So that made it an observational study. So let's take a look at the next page. This one's going to go fast. Quick summary. We have 3 types of statistical studies. Your observational, your survey, and your experiment. You always need to avoid bias by making things as random as you possibly can. Cause and effect can only be determined from experiments. You cannot determine a cause and effect from an observational study or a survey. And again, in an experiment, it is important to make sure everyone is randomly assigned. They're randomly assigned into the 2 groups and then randomly assigned treatments for it. And then some more vocabulary down here. Put yourself a little note. Study. A subject is just a person participating in the experiment. Treatments are the conditions to which the subjects are randomly assigned, so whether they're getting one thing or the other. Response variable, this one's tricky. Response variable is a variable that is not controlled by the experimenter and is measured as part of the experiment. And then randomization. Random selection refers to randomly selecting a group of people, where random assignment means you randomly assign them to a different group. So there's those 2 different things, but they sound very similar, so you gotta make sure you know those. And then